Welcome to this session. This session will give another example on how to resolve forces on an inclined plane. So the problem reads, a particle of mass m is pushed up a smooth plane, a smooth slope. This term smooth is key, and its meaning or its interpretation is that we neglect frictional force by a force of magnitude 5g newtons acting at an angle of 60 degrees to the slope. Then this causes the particle to accelerate up the slope at a speed of, or at an acceleration of 0.5 meter per square seconds. So find the mass of the particle. So let's draw a diagram to illustrate the information given in the question. So assuming that this is the slope, so let this slope have an angle of 0 theta. So let the particle be at this point. So the particle, we have been told that force of magnitude 5g newton acting at an angle of 60 degrees to the slope. So we have a force to this particle here of 5g newtons, and then this angle is 60 degrees. You see, the interpretation of this one is that if you extend this line, if you extend this line, then the weight will be acting in this direction. And because this angle is 60, so expect this one also to be 60 degrees. And because this line and this line are meeting at 90 degrees, so expect this one to be. So because, just a minute, so we have 60 degrees. And then this given as 30 degrees, so this 90. Oh, this theta was already specified in the problem. This was already given as 30 degrees. So initially the inclined plane just draw it this way. So this is the surface. We have the particle here. Meeting the inclined plane at 60 degrees. Then you draw the weight. Now remember the normal reaction, this is the smooth plane. So this is the weight. And so usually the normal reaction will be perpendicular to the surface. So this angle is 90 degrees. So it tells us that this angle here, this will be 30 degrees. So which means this is also 30 degrees. So because this weight makes an angle of 90 degrees with this horizontal to the plane, this will be 60. And so this is 30 degrees. Yeah, so that's 30 degrees. So this, we have 5g newtons of this weight of that given the magnitude of the force acting on the particle P particle at this point. And then this is the normal reaction force. So then now we do the usual stuff of resolving the forces. So if you draw a right angle triangle here, then this one will be W cosine of 30 degrees, because this angle is 30. And then this one will be W sine of 30 degrees. Similarly, we can actually see the same thing, that this is now, if you have to use this one, then this one will be R, or this now this will be this size of the force, which is simply given by 5G, and then cos of 30, and this will be 5G sine of 30 degrees. So horizontal forces so net force is usually given by M times A by Newton's second law of motion. So X component will be given by 5. Remember, this line here is parallel to this line here. So this is what I'm taking like my x-axis. So this will have 5G negative 5G so 5, or using this using this so this will be coming this way and then this way. So we'll have X component, we'll have W, but in the negative direction. So we have negative W sine of 30 degrees. And then you see this is the direction of force. So this is direction of force. So this now force is going in this direction. And then we have this direction here. So we'll have plus 5G cosine sine of 30 degrees should give us mass of the object is given as m times acceleration is given by 0.5. So times 0.5. So this would be minus mg sine 30 degrees plus 5g sine 30 degrees is equals to 0.5 m. So we can say minus m times 9.8 sine 30 degrees plus 5 times 9.8 sine 30 degrees is given by 0.5 m. So which tells us that so this will be minus 4.9 m plus 5 times 9.8 times sine of 30 will give us 24.5 equals to 0.5 m. Collecting m terms, we'll have 0.5 plus 4.9 which is 5.4, M is given by 24.5. So 24.5 divided by 5.4 will give us 4.5, 4.537,037,037 kilograms. So roughly M is 4.537 kilograms to 4 significant figures. So that is how we solve for M in that given problem. Thank you.